Hello guys. Hello guys. So today we are going to start with the TypeScript series. After the JavaScript series, we are going to do TypeScript. My original plan was to do React, but I'm waiting for them to complete the new doc. It's just better to go with like learning hooks and doing that perfectly rather than sticking on to old class-based system, which is not much ideal. It's not also a lot comfortable and like it's not used. That's the reason it's not used. Okay, so let me just transition and yeah. So I've gathered a few skills on OBS and I'm happy. Uh, though not a lot. I also made some changes in naming scheme. I updated a few things. I thought about a few things. JavaScript series was a series that wanted to do to test out how it will work, how things would work. Though it ran out for so long, it took almost like in real streaming days, it took almost a month, and a month is actually a lot of time because almost every video is of 1 hour of content, and um, it's difficult to actually speak for so long. So that's the main problem, speaking for so long. Um, is there anything else? Uh, okay, I also have a new hairstyle for uh, not something that I did for this, but yeah. Okay, so I look quite different. But yeah, l- with no further ado, let's just start. TypeScript stands in an unusual relationship to JavaScript. So basically, from what I know about TypeScript, TypeScript is like a superset of JavaScript. Okay, so everything that is JavaScript works in TypeScript, but then it also gives you a type system. It also gives you generics and all that to basically add some features to JavaScript. It's developed by Microsoft, and Microsoft only maintains it. And like I don't know if it's open source right now. Let's just check. Type SCRIPT Git. I guess it is open source. Yep. Oh, let's start this. Okay. Okay, it's open source. It has contributors, like users and contributors. Okay. Let's just get right straight into it. TypeScript offers all JavaScript features and an additional layer of TypeScript type system. For example, JavaScript. Yeah, exactly. This means your existing. Yeah, that what I said. Types by inference. So basically, TypeScript is smart enough to understand what types, if you do initialize and declare a variable at the point. So TypeScript is smart enough to know that, okay, this is a string, so the type of hello world is a string. So I shouldn't, if we come here. So now basically TypeScript says that hello world is string. So and um, okay, so you can use this uh, means comment to know, like same for numbers, same for all the other. So by understanding how JavaScript works, TypeScript can build type system and accept JavaScript code, but has type. Uh, This offers a type system without needing to add extra characters and make types explicit in your code. That's how TypeScript knows that hello world is a string in the above example. Okay, yep. Defining types. You can use wide variety of design patterns in JavaScript. However, some design patterns make it difficult for types to be inferred automatically. For example, patterns used for dynamic programming. Exactly. To cover these cases, TypeScript support an extension of JavaScript language which offers places for you to tell TypeScript what type should be. For example, let's create an object infer type. So we create an object and the type is inferred here. So if we do this and we add in, okay, it does not work for, I guess. Let's just try to add this. I guess it does not work for objects that comment. TypeScript works. Let me be clear, but I guess that comment does not work. Yep, this comment does not work. Which is okay. We understand what happens. With interfaces, you can explicitly declare types. So we are declaring an interface user, and you write for that the syntax is interface user, and in curly brackets you write the key and the type, and that's how you write the colon and the interface name to um, explicitly say that this should be of this type. Um, TypeScript also has a type keyword which does the same thing, but I've seen a lot of people use interfaces. But it's actually the same thing. I myself don't understand what's the difference. Though I haven't also tried searching it a lot, but I guess if there's a difference, then we'll find it out. And this, if you provide an object that does not match the interface you have provided, TypeScript will warn you. Exactly. Since JavaScript supports classes object-oriented programming, so does TypeScript. You can use an interface declaration with classes. Interface user class user account name string constructor, and now we are using the interface to basically mm, get this like do type checking for the user variable. So you see that in the class it does not matter that uh, like what type, like there are no types here. Like there is no type for the class, but the variables itself have types. The function, the parameters have types. So and the then we basically, what I'm trying to say, whenever we declare a variable, we have to add type. So class is not being declared, so that's not uh, having a type, but like these all have a type, and then this declaration has a type. If I was clear, I hope I was. Um, you can use interfaces to annotate parameters and result values to function. Let me be clearer here. Basically, you add types to every declaration. Simple as that. Uh, and, and if not, try to initialize it so it could be inferred. There is already a small set of primitive types and available in JavaScript, Boolean, yep, which you can use in types uh, as in an interface. TypeScript extends all lists of few such as any. So any basically is like you are saying that it could be anything thing like it could also be a string, it could also be a number, a variable could also be a string, or variable could also be a number. And generally it's very much discouraged to use any. If you have any special cases, then probably use it, but it's a good practice to not use. uh, Unknown ensures something using the type declares what type it is. So you use unknown. No, basically, as the name suggests, like you use unknown. no, to say that the type of this is currently unknown, and whenever it becomes known at that time. Never it is possible that this type could happen. And okay, uh, I'm not much aware about never, but it also say gives us an example for unknown. I guess let's just go through unknown also. Unknown is one of these type, those type that one clicks, you can fi quite find quite a lot of usage of it. It acts like a sibling to any type where any allows for ambiguity. Unknowns require specifics. A good example will be wrapping a JSON parser. JSON data comes in many different forms, and creator of JSON parsing function won't know the shape of the data, and the person calling that function should. JSON parser equals to JSON string, which is a string, and JSON.parse JSON string. My account JSON parser name. Okay, my account dot name, my account dot email. Cool. That's inferred. JSON parser unknown. If you hover the JSON parser, you can see that it has the return type of any. Okay, yep. Uh, it is possible to fix this with generics, yeah, but it is also possible to fix this with unknown. Okay, so basically it's a semantic difference. I guess it looks like a semantic difference where any is very much discouraged, and basically says that it could be anything. Unknown says that it's not known right now. Uh, cannot be used until the type has been declared to TypeScript. This can be used to ensure API consume. Okay, so Jason, I unknown also basically uh, forces us to add a type to this. So if, like, let's say we had this user declared somewhere here, and now I guess this would also work. This should work. Okay, no, it does not work. So this only works. Okay, so there I was wrong. So basically, you have to, like, if something is unknown, then you have to like basically force a type on it, and unknown basically forces a type, like forces you to add a type, which maintains the TypeScript ecosystem solid basically. TypeScript when you are using any again and again, because in that case it's just better that you had used JavaScript. Um, so unknown is a great tool to understand it more. Read this. Okay, never. Because TypeScript supports code flow analysis, the language needs to be able to represent the code logically cannot happen. For example, this function cannot return, never returns, throw new error, always throw never return. The type you see never, which means it should never. Having a function never return can be useful for when dealing with unpredictability of JavaScript runtimes and API consumers that might not be using types. Validate if user return user dot name not equals to not a number. according to the type system, this code path can never happen, which matches the return type of never return. Okay, so as like never returns, when a function never returns, can be useful when dealing with unpredictability of JavaScript runtime and API consumers. What are the okay? Let's just okay. Hmm. What can never happen, which matches the return type of never return. Okay, this is a little difficult to understand. Having a function never return can be useful when dealing with unpredictability of JavaScript runtime and API consumers that might not be using types. Okay, validate user, and if user return user.name not is question not a number. Cool. According to type system, this code path can never happen, which matches the return type of never return. The type definition states that a user has to be passed in, but there are enough escape values in JavaScript whereby you can't guarantee that exactly. Using a function which returns never allows you to add additional code in place which you should not be possible. It returns allows you to add additional code in place which should not be possible. This is useful for presenting better error message or closing resources like files or loops. Okay, so basically, um, the point of never return is to use it in places in code where you logically think that that could not happen, but like JavaScript has so many quirks, let's say, where and you might not apply that is present in JavaScript. So to solve catch those problems, catch those errors, you use a function that returns never. Returns never allows you to add additional code in place which should not be possible. This is useful for presenting better error message on resources like files or loop. A very popular use of never is to ensure that switch is exhaustive, that every path is covered. Here's an enum of exhaustive switch. Try adding a new option to the enum, maybe tulip. Okay. Let's just read it first and switch flower, case flower dot rose, return. We have four returns. Okay, let's try to add tulip. Okay, so we have an enumeration, and now uh, basically we find that all the cases are not there. So that case because Uh, okay, okay. So in that case, the default gets active. Basically, in that case, it will go to the default. Exhaustive check will fail, and uh, that's why the TypeScript system. Basically, as flower is not of type never, it will come like, and there is a case when this will come to this block. That's why the exhaustive check will fail. So let me be clearer. Uh, we have an enumeration here. Okay. So now, if they are like when there were only these four cases for in the enumeration, any one of these case would have been met. Okay. So it would never reach default. Therefore, TypeScript also didn't care about this. It knew that okay, it would never be there. So chill out. Let's chill out. But as soon as you add a new value in the enumeration, now TypeScript knows that TypeScript is smart enough to know that um, default will get active when it's triggered. So this now it finds that there's an error in this code because it's of type never, but it's getting a type flower. So which is this, and therefore for it will uh, basically give you an error. Never's complicated. Um, you will get a comparison error saying new flower type cannot be converted into never. Never in unions. Never is something which is automatically removed uh, from a type union. Never is new. Okay. So type. So this is the different syntax for basically defining types, and like if you add curly braces here and add an object like system, then that would be same as interface. A lot of people use interface though. If you for like uh, I guess we can write it in the face. Okay, so yeah, I'll show you that example, which I know, but I guess this is the exact use for type keyword, which I wasn't aware of. But like say we can also use it like this type. Let's say ABC is equals to and ASTRING uh, B number, and this is also a way that like it's the same as declaring it with interfaces. So um, like we saw, yeah, it's similar to this. So that's it. If you look at the type never is removed, you see that yep, because it should never happen in runtime because it cannot assign a distributor. Let's go. You can use interfaces to annotate parameters and return values of function. Function get user, admin user, user, delete user, user. Okay, we basically uh, this is basically telling us that it will return a user, and this is telling us that it requires a user type user. There is already small set of primitive. Exactly, we did this. You you'll see that there are no two syntax for building types exactly. You should prefer interfaces use type when you need specific features. Basically, this is the use of type, or else use interfaces. Um, that's the reason like a lot of people don't see interfaces a lot. Composing types. Let's see if I have any comments now. Uh, I do miss it sometimes. Uh, no, okay. Uh, like the video if you like it. Um, it's your choice. Uh, I prefer you like, but it's your choice. With TypeScript, you can create complex types by combining simple ones. There are two popular ways to do so, with unions and with generics. With unions, you can declare that a type could be of many types. For example, this is the way to do unions. Um, it- you marble type boolean basically like as true and false is basically type boolean, so that's why it's giving us its type boolean. A popular use case of unit types describes set strings number. So now you can add these like strings or numbers to basically if you want it to be only particular values. Union provides a way to handle different types too. For example, you may have a function that takes an array or a string. Um, Let me just get my charger once I'm done with this topic. Uh, Union provides a way to handle different types too. For example, you may have a function that takes an array or a string. Okay, okay, uh, it takes a string and an array of string, and it gives us the length. Uh, you can even make it more complicated by making this a type and making it a type of numbers union, string union, boolean, and all that. Type of could be used to get the type of object is equals to string, return object here, generics. I guess I'll finish it before my battery dies. It looks like it because it's just of like one page of content is left. Generics provide a variable to type. A common example is an array. An array without generics could contain anything. An array with generics can describe the value that array contains. Okay. Type string array is equals to array of string. Type number array, array of number. Type objects with name array of the object. Uh, we also like many times we also declare, let's say, like above we saw the user object, like user interface. So we declare the interface and we add in square brackets to say that it's a array of user. So like we do it like this with and instead of string we will write capital U as SER. You can declare your own types using generics interface. Uh, this is the main use of generics. Uh, so backpack, we get a type and add will be a function which takes an object of type and gives in void and get gives in basically returns the type like object which is of type so many types. Declare constant backpack and basically if we pass in string, so now add will take in basically a parameter of named object which is of TypeScript returns void, and get will returns void but it means returns nothing, and get will be like returning a string. Now, as we add 23, it gives an error. Structured type system. One of TypeScript core principle is type checking focus on shape and the values that values have. This is sometimes called duck typing or structured typing. In structural type system, if two objects have same shape, they are considered to be of same type. Interface point xy number uh, log point console log p.x and yep, they are of same type exactly. One of TypeScript core principles is to type check focuses on shape that value have. This is sometimes called duck typing. Okay, it's just a naming thing here here at till this point. The point variable is never declared to be point. However, TypeScript script compares the shape of point to shape of point in the type check, and they have the same shapes, so the code passes. The are they using the yeah, so we are okay. We are using log point. Okay. Uh, the shape matching only requires subset of object fields to match. Okay. So okay, this I don't know. So now as the subset has this x and y, so it will pass in x and y, and that will work. That also has x and y. It will work, but color does not have that, so it won't work. There is no difference between how classes and objects conform to shape. Class virtual point in the xy number constructor xy cons new point is equals to new virtual point 30 means yeah. So classes are basically syntactical sugar on objects. We know that from the JavaScript series, and it's like we shouldn't be scared of when we see classes because basically they are objects. In the object or class, all the required properties type will say that match regardless of the implementation details. Syntactical sugars doesn't change anything. It's just the same thing. Next steps, we'll do the handle book, I guess. Uh, I guess we'll take two topics. Hmm. Yep. Okay. Bye bye, guys. Thank you for joining. I guess no one joined, but one person did join. Thank you for being here, and anyone that sees in the future videos, thank you. Uh, Bye bye.